This is Module 2, Lesson 10. How can we describe with precise language how to sequence rigid motions so that one figure maps onto another? Please open up your binder, turn to the Lesson 10. It starts with classwork. It's questions 1 through 5. For each problem, we're going to do 5 exercises, and for each one, we're going to go into more detail on how to describe the different rigid motions that will map one figure onto another. So we already know that the order in which transformations are performed makes a difference. We've seen that already. For each of the next exercise, we're going to go into more detail. Number 1, in the following picture, triangle ABC can be traced onto a transparency and mapped onto triangle A prime, B prime, C prime. So it's going to help if you have a page protector or a transparency, or even if you have wax paper, because you can see through wax paper. You might be able to try that if your parents have that at home in the kitchen. So which basic rigid motion or sequence of would map one triangle onto another? So we've got triangle ABC and triangle A prime, B prime, C prime. I just want you to make you aware and make you notice the markings on the triangle. And I think you've learned this before, but just in case, this marking here, this one curve mark, signifies that these two angles, the angle B on the top triangle and the angle B prime on the bottom triangle, that they are the same measurement. Likewise, angle C and C prime are the same measurements, and that's delineated with 2 curve marks, because we don't know if B and C are the same measurement, but we do know that B and B prime are the same measurement, and C and C prime are the same. So B gets 1 marking, 1 curve mark, and C gets 2 curve marks. If they are in fact the same triangle, then you could take it a step further, and A could have 3 curved lines, and A prime would have 3 curved lines. That's just a side note, okay? So, so it's obvious if you use a transparency that you could reflect the bottom triangle over the top triangle. So that would be an answer. But we want to make sure our answer is precise and accurate and a little bit more detailed, because that's what's required to show that you have an understanding of basic rigid motions. So you could say a reflection, but a more precise answer would be it's a reflection over line BC. And if you did that with your transparency, that's what you're reflecting over. That's what you should see. Okay? At any point in this, you should be stopping the video and answering the questions before you go through this with me, because for you to copy this and not really understand it kind of defeats the whole purpose, because you're going to be coming in tomorrow with questions. So you need to stop, do the work, and then start the video. So now let's look at question number 2. Question number 2 says, in the following picture, triangle ABC can be traced onto a transparency and mapped onto triangle A prime, B prime, C prime. Which basic rigid motion or sequence of would map one triangle onto the other? And here this triangle has the mappings again also. Well, I think it's obvious if you played with your transparency and moved it around a little bit, that if you rotate the triangle, you would map one onto the other. So that would be an answer. But a more precise answer would be a counterclockwise rotation of d degrees around point B, where B is the center. So you're adding in the direction. You're saying how many degrees it is. It's d degrees. You're saying what the center is. What's the point of rotation? Where B is the center. That's the difference. That shows that you know a little bit more than normal about how to do these basic rigid motions. You know a little bit more than somebody who just read a definition of them. Okay, question 3 says, in the following picture, triangle ABC can be traced onto a transparency and mapped onto triangle A prime, B prime, C prime. Which basic rigid motion or sequence of would map one triangle onto the other? So if you tried this, it may have been obvious to you to do a rotation and a reflection. But let's give a more precise answer. A more precise answer would be a counterclockwise rotation of d degrees about point B, followed by a reflection over line BC. You're not just saying it's any reflection, you're actually giving the point, the line, I'm sorry. Now, you could say that you wanted to reflect first and then rotate, and you can do it in that order. But we need to be precise, so we need to be able to state what the line of reflection is. So if you decide to reflect and then rotate, you have to find your own line of reflection. You can be just as precise by rotating about point B and rotating in a counterclockwise direction. And then B prime, C prime meets B, C, the sides meet together, and that would be the line of reflection. And then you could just reflect it over that line. So the order doesn't matter, but how you describe it will make a difference in how, if you do a rotation and then a reflection, or a reflection versus a rotation. And the line of reflection already exists for us if we do a rotation and then a reflection. It doesn't exist at all if you want to do a reflection first and then rotate it. Okay? Okay, question number 4. In the following picture, we have 2 pairs of triangles. In each pair, triangle ABC can be traced onto transparency and mapped onto triangle A prime, B prime, C prime. Which basic rigid motion or sequence of would map one triangle onto the other? So we've got 2 scenarios here, so you should stop the video and try different scenarios and see how you could get the pre-image to map to the image in scenario 1, and the image to map to the pre-image to map to the image in scenario 2. So stop the video and try it. It may take you a few minutes to figure out how to make it work. Okay, so let's look at scenario 1. For scenario 1, we can translate and then rotate. That was obvious. We did a few of those today in class. But let's be more precise. A more precise answer would be we can translate along vector B prime, then a counterclockwise rotation of d degrees around center point B. So you see the difference in how much more precise it is. It says exactly the vector we're using, and then it says the direction of the rotation, how many degrees, and what the center point is. For the second scenario, we can translate, reflect, then rotate. But a more precise answer would be we can translate along vector BB prime, then a counterclockwise rotation around center B, then a reflection across line BC. So if you're not sure how that happened, you need to go back to scenario 2, translate along the vector BB prime, then make a counterclockwise rotation around center point B, then reflect across line BC. Now you could have picked another vector, but that may or may not change what line you're reflecting across. So you can come up with, you may have other scenarios that would work for you. So if you do, that's fine. Let's discuss them when we discuss this lesson, and let's see if other ones work. Okay? The last one is let 2 figures, ABC and A prime, B prime, C prime, be given so that the length of the curved segment AC equals the length of the curved segment for A prime, C prime. And the absolute value of angle B is equal to the absolute value of angle B prime, which is 80 degrees. Degree measures, in this case, they want to make sure you understand they're positive degree measures. The size of the angle is a positive measurement. We're not talking about direction, we're talking about the measure of an angle. And the length of A prime B prime and the length of AB are both 5. And remember, length or distance cannot be negative, so they're putting it in the absolute value symbol just to reinforce that point. With clarity and precision, describe a sequence of rigid motions that would map figure ABC onto figure A prime B prime C prime. So stop the video and try to see how you could, with your transparency, map one figure onto the other and see what you can come up with. So you should have seen that you could map one onto the other by doing a translation, a rotation, then a reflection. But we want to be more precise and have more clarity in our answer. So a more precise answer would be to translate along vector A prime, then a clockwise rotation of d degrees about center point A, followed by a reflection across line AB. If you tried something else and it worked, that's fine too. We can discuss that when we discuss this lesson. But for me, this is what worked for me, and it required me to do a clockwise rotation rather than a counterclockwise rotation. So please be prepared with questions on lesson 10 tomorrow. I will attach to the calendar, along with this lesson, a video that you've watched before, but I'm going to have you watch it again because it includes all 3 basic rigid motions, and I think rewatching it again might reinforce certain properties and might just help you along this process. So this concludes lesson 10.